Hello class, this is Ms. Riggins with today's video on 4.4 applications to compound interest. As you're watching the video, please remember to write down important notes, statements, equations, as well as any questions you have. Feel free to pause or rewind the video as you need to, and feel free to watch the video as many times as you so choose. Don't forget at the end of the video to write down your summary of the video and submit it via an online WISC form before class. All right, let's begin. Today I'm very excited about this video because it's about a topic of math that we use in real life situations that you may not even realize are being used. And that's the area of compound interest. And this is really used in the banking field as well as the credit field. In any type of financial field is where you're going to be using compound interest. Before we start with talking about compound interest, let's take a look at two different scenarios. Suppose you have $500 that you want to deposit in a bank account for 5 years, and you go around and you search for different bank account options. And you have option A, which says the bank will pay you 10% simple interest after 5 years. So you keep your money in the bank for 5 years, and at the end of 5 years, the bank will give you back your money, plus it will give you the interest, the simple interest earned, which is 10% over the 5 years. Option B is the bank will pay you 5% per year, compounded quarterly interest. And for those of you who don't know what quarterly means quarters, 4 quarters in a year. So basically they will compound the interest or apply the interest 4 times in 1 year. And the interest will be 5%. And so you say, well, which option should I take? The one with the larger interest or the one with the interest but compounded more frequently? Because simple interest is only charged once. In this case, since you're going to keep the money in after 5 years, it's only going to be charged once after 5 years. Where since we're option B, which is compounding it quarterly, it's going to be charged interest, or interest will be applied 4 times a year for 5 years. So you're talking about 20 times will the interest be applied. Although not that same 5% for each 20 times, is 5% per year as well. So let's take a look at the options. Well, after 5 years, simple interest, which means interest charged or added once, will get 10% of 500 is $50, and therefore the total amount you'll get back at the end of the bank, well, at the end of the 5 years, is $550. Then option B, which is compound interest, which means basically interest is earning interest since it's being charged throughout the duration of a year or multiple years. So after the first quarter, you're going to be charged interest. Interest is going to be applied, not the whole 5%, because remember it's the first quarter of a 4-quarter year. So you're only going to be charged a fourth of the 5%, or applied the fourth of the 5%, and which ends up being $6.25. So after the first quarter, what's in the bank account is $506.25. But here is the beauty, which is why they talk about interest earning interest, is on the second quarter, the amount that's going to be applied interest on is not just the $500, but the amount that's been in the bank account for the second quarter, which would be $506. So we're going to apply interest to the $506.25, not the full 5%, but a fourth of the 5% because we're on the second quarter. And that will be an additional $6.33. So at the end of the second quarter, you have $512.57 in your bank account. You do the exact same thing for the third quarter. Apply it not to the 506, but apply the interest to the 512.57. And you're going to get at the end of the third quarter $518.98, and vice versa. So after a year, you won't have $550, but you will have over $520. So since we're looking at this for 5 years, which means 4 times 5, i.e. 20 quarters, then the final amount after the 20th quarter or the 5th year is $644.02, which is definitely more than the $550 charged after for simple interest or once. And so let's take a more in-depth look at this. So there are some terms that banking institutions and financial institutions use that you may need to know, especially as you're solving these word problems. One of the first terms is the idea of a nominal rate, which was R. In this case, it was 5%. And we represent that in decimal form, which is 0.05. And in this case, when we talk about compounded, even though in our example we compounded quarterly, which is 4 times a year, you can compound annually, which is once a year. So each time you compound, you're charging R divided by 1, where R is the interest, or the nominal rate. Semi-annually is twice a year, so you would be charged at each time R over 2% interest. Quarterly, which we did, which was 4 times a year. At each time you compound, you're going to be charged R divided by 4, which is what we did here in this example. Monthly is 12 times a year, or R divided by 12. And daily is 365 times a year, which is R divided by 365. So, of course, ideally you want to be charged, or you want interest to be applied more often so you can get more money. And different banks have different stipulations for that. So the nominal rate is R, but why is it that we want to be charged, we want to have interest be applied more often in 1 year? Is because of what the actual annual effective rate will be after 1 year. And so we call that effective annual rate, or annual percentage yield in America. If the nominal rate is 0.05%, then to figure out the 1 year of interest, it will actually be, of course, the growth rate will be 1.05. So the annual effective interest will be 0.05. Let me scroll this up. If it's semi-annual, twice a year, if I do this calculation, I get 1.050625. So the annual growth rate would be 5.06%, even though the nominal rate is still 5%. If it's quarterly, then the annual percentage yield will end up being will be 5.094453%. If it's monthly, the annual percentage yield will be 5.11%. And if it's daily, the annual percentage yield will be 5.12% per year. So even though the nominal rate is the same of 5%, the actual annual interest rate, so as you can see, it's going to be about 5.13%. The longer the more oftentimes you compound in a year. So let's take a look at this statement that's in the book. And it's good to note. And it looks very similar to our exponential function that we looked at in the last video. So if interest is at an annual rate of R, in other words, the nominal rate of R, is compounded n times a year, so 1, 2, 4, 12, and 365 are the most common compounding times, then R over n times the current balance is added n times a year. And that's one of the most important statements for how you calculate and apply interest. R over n times the current balance is added n times a year. So if I have an initial balance, remember our initial value of the exponential function was A, well this time we're calling it P, and the balance is t years later, then this is P times the 1 plus, if you guys remember, that looks very similar to, let me put it down here, I. So like I said, it looks very familiar, but B is the same thing as 1 plus R, where in the previous thing, R was just the growth rate, a growth factor. Well, anyway, we have the same thing, but instead of R, it's R over N, where N is the number of times interest is compounded a year, and T would represent the year, but in this case, N times T will represent the number of compounding periods in that so many years as well. And so the formula is it's an exponential growth formula, which is why it's 1 plus, and that R is the nominal rate, and N represents the number of times it's compounded a year. So I encourage you to look at the examples in the book on how to calculate other problems. We did show you how to calculate the APR, but you can also look at other examples of that. All right, that's it. Thanks.